Now, if a question asks you to solve a triangle, that means that you need to find all the side lengths and angle measures that aren't given. So for this triangle, we're going to say that the longest side is, or we'll put R up here, and it's triangle RST. And we're given that R is equal to 12 meters. So that means the side opposite angle R is 12 meters. And we're also given that T is equal to 8 meters. So that's the side opposite angle T. So T is equal to 8 meters. And we're given that angle S is equal to 65 degrees. So what we're given here is an angle, or two side lengths and the contained angle. So that means we have to use cosine law. And so our formula is going to be S squared, because we're going to look for side S first. We're going to try and find the side length opposite angle S. So S squared is equal to, and we'll sub in, but we're going to write R squared plus T squared minus 2 RT cos of S. And we're going to sub in then for the values that were given in our diagram. So R is equal to 12 squared plus 8 squared minus 2 times 12 times 8 times cosine of 65 degrees. And what we're going to do, since this is what S squared is equal to, S is going to be to the square root of this whole thing. So we're going to find the solution to all this, and then we're going to take the square root of the answer. And we're going to let our calculator do a lot of the work here. So when I call up the calculator, so we have 12 squared plus 8 squared minus, and I'm going to put in brackets just in case we have difficulties here with the calculator not doing what it's supposed to. So it's 2 times 12 times 8 times, and it's 65 cosine. And we're going to close the bracket and hit equals. And we're going to take the square root of that answer. So all this, so R squared plus T squared minus 2RT cosine of S comes out to be a little over, almost 127. And so we're going to take the square root of that, and it comes out to be approximately 11.3. And if it doesn't tell you, usually the teacher wants you to round to 1 decimal place. So S then is equal to approximately 11.3. And the units are going to be meters. Now, by this, so this is 11 meters. 11.3 meters, and that's what S is equal to. We can now use sine law in order to find other angle measures. And keep in mind, we should be able to estimate here, because side length and the angle measure are related to relative to one another. So we expect T to be the smallest angle because it's the smallest. Small t is the smallest side length. R is going to be the largest angle because it's opposite the longest side, and S is going to be a little bit smaller than R, and because it's mid-range. So we expect T to be greater than 65, but not by a lot. So we'll check that now by using sine law, and we're going to use R over sine R is equal to S over sine S. And so R is equal to 12. Sine R is what we're looking for, and this is equal to 11.3, which is the measure of s, over sine of 65. We cross multiply, so 11.3 times sine r is equal to 12 times sine 65. And we're going to divide both sides by 11.3. And this is 12. And so r, angle r, is going to be equal to the inverse sine of 12 times sine 65 divided by 11.3. So when we call up our calculator, this is going to be 12 times 65 sine divided by 11.3, and then we're going to take the inverse sine. So this is equal to 74 degrees, and we can use 74.2 degrees. So, but we'll just use 74. And so that means that that's the measure of angle R. And so going back up to our original question, original part of the question here, so this is 74. Remember that we estimated it to be greater than 65, and not too much greater, but a little bit greater than 65. And so now just to find angle T is going to be equal to 180 minus the measure of the other two angles, so minus angle R and plus angle S, so it's going to be 74 plus 65. So this is 180 minus 139. And so angle T is 41 degrees. So now we have all the angles and all the side lengths from the original information.